This lesson will teach me to apply exponent rules to scientific notation. First, let's do a brief refresher on scientific notation. Scientific notation is a way that is used to write really big or really small numbers. The trick to scientific notation is that there always is going to be a number, which I've used the letter A to represent, times 10 to some sort of an exponent. However, there's some stipulations for what this number can be. It needs to be 1 or larger, notice the greater than or equal to, but at the same time less than 10. Notice all of these fit in between those numbers. They're larger than 1, but at the same time less than 10. And then we'll discuss what the exponents mean here in a moment. Standard notation is the normal way that we write numbers. Let's look at some examples. The first one says 2.07 times 10 to the fourth. Notice 2.07 fits between the range specified on the previous slide. Numbers that have a positive exponent are large numbers. These are numbers that are, think about miles across the globe or miles between here and the moon. They're large numbers. This is telling me that it has 4, I'm moving the decimal places 4 places. I need to make this number so that it looks like a really big number. So I'm going to move it this direction. 1, 2, 3, 4. So 4 directions to the right. All of these places that are empty, for instance this one and this one, get filled with zeros. So here, let's double check one more time. 1, 2, 3, 4. So the 0 filled a spot, the 7 filled a spot, and then I filled them with 0, 0. Negative exponents make numbers smaller. Think about what negative exponents do with our exponent rules. Negative exponents make fractions. Well, fractions, if you were to consider, for instance, the number 1 over 100, that can be converted to a decimal. So even though negative exponents make fractions, fractions make decimals, which is why this idea of a negative exponent represents a small number. Think about the size of a germ. It's going to be teeny tiny or microscopic. So to make this number smaller, we're going to get 0 so that they're on the left side, meaning we're moving the decimal place 3 to the left. 1, 2, 3. And I'm going to replace any of those little bumps that don't already have a number in them with zeros. Anything to the 0 power is 1. So 5.4 times 10 to the 0 should just be 1. So anything to the 0 power is 1. Whoops. So that means that this becomes a 1. So it's essentially 5.4 times 1, which is 5.4. Or if you think about it, we're not moving the decimal place any positions. This one here, 3.495 times 10 to the 1 power. Even though it's to the 1 power, it's still telling you to move the decimal place 1 to the right. So it's 34.985. So not really that big of a number, but it still is representative of a larger quantity. So negative exponents make the number smaller. You move the decimal place to the right. And positive exponents make the number bigger, so you move the decimal to the left here. All right, so let's try it the other way. Rewrite from standard form into scientific notation. Again, negative exponents make numbers smaller, positive exponents make numbers bigger. In letter A here, this is a pretty big number. In order to be in scientific notation, I need to have a number times 10 to the something. That number needs to be between 1 and 10. So in order to make it between 1 and 10, I need the decimal place to fall between the 8 and the 9. So if I started out here where the decimal place currently is, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So 8.937 times 10 to the 9th. Letter B, this is a particularly small number. I need the value to be between 1 and 10. So the decimal place needs to be 7.23, so that this number here is between 1 and 10. Now let's count how many places to move it. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is going to be a negative 9 because it made the number smaller. Let's see. 73 is definitely larger than 10, so I need that decimal place to go here. If you notice, I moved it one spot, so 7.372 times 10 to the 1. And let's see as well, this next one, gosh, if it could be here, I'd have 2.3, which is kind of where I need it. So 1, 2, 3, 4. But notice that this value is small. So because it's a small, it gets a negative exponent. Remembering again, those negative exponents make fractions. Fractions make decimals. So the ones with these really crazy decimals get the negative exponents. All right, look at the following. Is each in correct scientific notation? If not, correct it. Saying it again. When we talk about that number times 10 to the something, that needs to be between 1 and 10. This value is just underneath 1, but if it could be 9.2 as opposed to 0.9, then we'd meet this stipulation. How do we make that happen here? What I do is I kind of think about the number fixed. If I say fixed, I mean put back in standard form. So if it's times 10 to the 5th, I'm actually going to do that. Oops, let me get my pen. 1, 2, 3, 4, 5. So this is what the number started out to be. Now that I see the number and I recognize that I want the decimal place right here, now I take a second step and I actually make it the decimal place where I want it. 1, 2, 3, 4. 9.234 times 10 to the 4th power. So I realized, no, this isn't in correct form. So I'm going to put the number itself into standard form, and then from standard, put it back into a correct scientific notation. Letter B, is this in correct scientific notation? No, it's not. That number is too small. Recognizing that it's not right, I'm going to say, okay, to heck with scientific notation. This says -4, then that means 1, 2, 3, 4. 1, 2, 3, 4. So 0.123423. This is what the number should have been when it started, before the scientific notation got screwed up. So now, since I realize what the number is, I'm going to go ahead and fix the scientific notation for myself. I want it to be here. 1, 2, 3, 4, 5. 2.3 times 10 to the -5th. I'm not saying that there aren't patterns, and I'm not saying that there are shorter ways, but this always helps me. Letter C, is this incorrect scientific notation? Nope, because 73 is definitely larger than 10. It's not in correct scientific notation, so I'm just going to say, okay, let's go back and let's look at what the number was originally. 10 to the 6th power means 1, 2, 3, 4, 5, 6. 7, 3, 9, 4, 1, 2, 3, 4. 1, 2, 3, 4. Okay, now I want the decimal place, if it were correct, to be here. 1, 2, 3, 4, 5, 6, 7. 7.394 times 10 to the 7th. So it wasn't right originally. I fixed it in standard form, and then I went ahead and put it back into proper scientific notation. Lastly, letter D. This one still isn't right. Nope, not in correct scientific notation. I'm going to fix it. 1, 2. Well, that number is not terrible. And now that it's in standard form and this is the way the number was originally, I'm going to go ahead and fix it and do it the right way myself. Decimal needs to be here, so 5.39 times 10 to the -1. Listing the numbers in order from smallest to largest. A couple of hints. Things to look for. Order the exponents. So -28 is definitely the smallest exponent, so that's the smallest number. Now these have the exact same exponent. So look at, see the base that is smallest. and the base is the number here. 1.08 is smaller than 1.8, so it's going to go this one, and then that one. Simplify. Write the answer in scientific notation. Grab a calculator. Be careful with your calculator here, though. I think it's going to be harder to type it in as you see it. You know exponent rules, so use them. This one here, a normal number times a normal number. So I'm going to take my calculator and do 4.6 times 3, and he gave me 13.8, and I'm going to bring along the scientific notation. Notice this is not proper form, so I'm going to fix it. 1, 2, 3 would be the original, so I just got to put it correct. Times 10 to the 4th power. Your calculator can do it if you can enter it in right. What's the point of all the exponent rules if you can't use them? Let's look at letter B. Multiply your normal numbers. I grabbed my calculator, that gave me 19.24. When I multiply like bases, I add the exponents. Times 10 to the 1st power. Move it one place. Let's see, times 10 to the 1 means it's really 192, but I need it here. So 1.924 times 10 to the 2nd. It's another one, very similar. I'm going to take my calculator and I'm going to multiply those normal numbers. 0.8 times 0.4 is 0.32. When I multiply like bases, I add the exponents. That's not in proper scientific notation, so I'm going to fix it. 1, 2, 3, 4, 5 would be the right answer, but I need scientific notation, so put it back. 1, 2, 3, 4, 5, 6 is actually where it needs to go. Couple more. I only get a 15-minute video, so I'm almost out of time. This is division. Grab your calculator. Divide these normal numbers. Your calculator can do that with ease. 0.6 or 6.8 times 3.4 or divided by 3.4 is 2. Do you remember what you do when you divide like bases? Subtract them. Times 10 to the 10th power. Check that out. Proper scientific notation, no fixing needed. All right, next one. Ignore that. I wanted to start over. All right, so let's try this. Again, grab your calculator. Your calculator can, handle that division. Basic numbers. 2.7 divided by 9. I did it in my calculator and it gave me 0.3. The exponents here can be a little tricky, so hang tight. When you divide like bases, you subtract the exponents. So it's -8 minus a -4. Well, minus a negative is a positive or plus, so it's going to be times 10 to the -4th power, not in proper scientific notation. So -4 units would be to the left, 1, 2, 3, 4, but I don't want the standard, I want scientific. So 1, 2, 3, 4, 5 would fix it. All right, there you have it. That should be the end of your outline. Do the best you can and let me know what questions you have. Thanks so much.